All right. Today we're going to start on the projector. So in chapter 3, we're going to deal with derivatives. And we're going to talk about what derivatives are and how we find them and what they mean. So let me make sure it's being shared still. Shared screen. There. All right, in section 1, okay, first off, what are derivatives? Derivatives are a way for us to find slopes of a curve at a given point. Mm-hmm. Mm-hmm. Yeah. Yeah, I had to load up the stuff. I was busy at a conference all weekend, so I didn't have anything posted this past week. So I'll get everything today. So yeah, a derivative is just a way of finding a slope of a line at a given curve at a point. And what that means is, since it is a slope of a curve, it's the instantaneous rate of change of an object. So let's write this stuff down. Yeah, so in this section, we're going to talk about slopes. We're going to get tangent to a curve at a point, and the derivative of function at a point. And the derivative is a slope, instantaneous rate of change. Let's recap how we go from slope to a derivative. Say we have a curve. And we have a point here. And we have another point there. What we know so far, that if we drew a line between these 2 points, connecting these 2 points to that curve, we would find the slope of the secant line. Again, secant line crosses a curve at 2 points. The distance between these 2 points we call h. So in order to find the slope of a curve at any given point, what we need to do is we need to find the slope of the line tangent to that curve at that point. So we have to find the slope of the line tangent to the curve at that point, at x1, y1. How do we do that? Well, what we have to do is we have to move this point closer, closer, closer to one. Because as it gets closer to one, the secant line is becoming more and more and more like the tangent line. So what we want is this distance between x1 and x2, we want that to go to zero. We want the h to go to zero. Eventually what we want is x1 and x2 to be the same. So in order to do that, what do we need? We need to have an equation that has only one point. And we can't do it with this. So we can't find the slope of the line tangent with 2 points. So what we have to do is figure out how do we get rid of x2. Well, what we know so far is that x1 plus h equals x2. So if we start at x1 and we add h to it, if we add h, then we'll end at x2. So from here, we know the relationship between x1 and x2. So instead of writing x2, I can write x1 plus h. And even here, if I write, instead of x2, I have x1 plus h minus x1. The x1's cancel. And so what we have is a function this is the slope of the line tangent to the curve. At x. So that's what we're trying to find. We're trying to find the slope of the line tangent to the curve. Because once we find the slope of the line tangent to the curve, we can find the equation of the line. So the definition. The slope of the curve y, or f of x, at the point x0, y0, which is the point x sub 0, f of x0, so the slope of the line, slope of the curve at the point P because, as we said here, in order to get the slope tangent, we need to get x2 closer to x1. Eventually, we want x1 to equal x2. We do that by taking the h going to 0. What that means, if in order to do that, we have to take the limit as h goes to 0 of the two. F of x plus h minus f of x over h. So what does this show us? This shows us the slope of the line tangent to our function. So we have examples here. So here's our first example. Find the slope of the curve y equals 1 over x at any point x equals a, not equals 0, because that's the asymptote. What is the slope at the point x equals -1? Where does the slope equal -1/4? What happens to the tangent line to the curve at point a, 1 over a, as a changes? So what do you think we do first? A says find the slope of the curve. That's the first thing we have to do. How do we do that? How do you find the slope of the function? That's the slope. So we have f of x, which is 1 over x. H is just the distance between the points. What's f of x plus h? How do we find f of x plus h? Not yet. This is once we find the slope, we have to do that. We have f of x, we need f of x plus h. What that says is anywhere we see an x, just put a plus h behind it. That's what it tells us to do. It's not reciprocal. It's still 1 over x. It's 1 over x, but it's still 1 over x plus h. So our slope formula becomes 1 over x plus h minus our f of x, which is 1 over x. In order, we have to do the top first. We have an equation up on top. So we have to get common denominators. This one has an x plus h, this one doesn't. So it needs an x plus h, top and bottom. This one has an x, this one doesn't. So it needs an x, top and bottom. So we have a common denominator of x times x plus h. On the top, 1 times x minus 1 times x plus h. Of x plus h We'll distribute the negative sign to the second equation. So we have negative x, negative h. The x's cancel. So we have negative h on top. Algebraically, we have a compound fraction. We have a fraction on top and a fraction on the bottom. So we take the top fraction, leave it alone. Multiply by the flip of the bottom. Take the top fraction, leave it alone, flip the bottom. Cancel anything on top and bottom that can cancel, the h's. So only thing we have left on top is negative 1. X times x plus h on the bottom. You have a question? Because you're looking at it like it's got 7 heads. What's that? Yeah, so first off, we have to find f of x plus h. We know f of x, that's that one. So anywhere we see an x, we put a plus h behind it. So that gives us both of our functions. F of x plus h is 1 over x plus h, minus f of x is 1 over x. Just those. Yeah, so that's why I would just replace f of x plus h with this and that. And then we have to get a common denominator. This one has an x plus h. This one needs an x plus h, top and bottom. This one has an x. This one needs an x, top and bottom. Leave the bottom. We have a common denominator. Just worry about the top. 1 times x is x, minus 1 times x plus h is x plus h. Distribute the negative sign. X minus x cancels, minus h. Then we have a fraction on top of a fraction. And that's where we are. That's just, again, it's the algebra part. It's the calculus who hasn't even done yet. So we have to find the slope. We can't find the slope because it has that h in it. So the slope is when x goes to 0 of our slope. So as h goes to 0, we have x times x is x squared. So that's the slope of our curve. At any point. That's the slope of our curve at any point along the graph. The slope at x equals -1 was -1 over -1 squared. It's -1. That's the slope. So far, so good?
Yeah.
Okay, so we know the formula for a slope is this. This was all part A. Part B is asking for, where does the slope equal negative 1/4? So where does the slope equal negative 1/4? Yeah, we found the slope is negative 1/x². Where does that equal negative 1/4? Wherever x² equals 4, it equals negative 1/4 at x equals -2 and -1. It echoed here at -2 and here at +2. So once we found this equation, we found the slope. We could find out where it's at what point. Now, if it's asking for a point, it says, where does the slope equal 1/4? We know x equals that. So f of 2 and f equals -2. So those are the two locations. Those are the 2 points where it equals, the slope is negative 1/4. Because locations are points. Okay, I knew the x's. Yeah. I knew the function. The function is 1/x. So I plug in 2 and -2 in there, because this is y. So what happens to the tangent line at the point a 1/a as a changes? What happens to the tangent line? Let's see what happens when a goes to infinity. What happens as a goes to infinity of that? Where does this number go? It's a limit function, so you take the limit and plug it in there. As a goes to infinity, what happens to this number? As a gets bigger, what happens to it? No, no, we're not stretching. We're looking for a value. What number is it approaching? Look at the numbers. When a is 1, 1/1 equals 1. When a is 2, 1/2. When a is 4, 1/4. When a is 10, what's happening to the numbers? And if you keep on going to infinity, what do they approach? As 0. This number goes to 0. So as a goes to positive infinity, it goes to 0. Well, yeah, the number gets smaller, and smaller, smaller, smaller. Eventually, it goes to 0. So we're looking at this picture. As a gets bigger, the slope goes to 0. Same thing as it approaches infinity. As it approaches negative infinity, the slope goes to zero. As it gets to zero, as it goes to zero from both sides, what happens? If it goes from then we have a positive infinity. And then we have a negative infinity. Because it becomes vertical lines there. So it helps when we look at the picture. We know that this graph is 1 over x. So basically what this last question is asking is, as x changes, as x goes to infinity, the slope goes to zero. As x goes to zero, it goes to infinity. So there is no slope here. It's a vertical line. It's a horizontal line, sort of horizontal line there, and likewise here. As a goes to infinity, slope goes to zero. As a goes to zero from the right, the slope goes in positive infinity. As a goes to negative infinity, the slope goes to zero. And as a goes to zero from the left, it goes to negative infinity. It's pointing straight down.
So it's like developing, like it's like you're reciprocal, like inversely.
Well, they are, because our function is 1 over x. It's either going to be in first or third quadrant. All right. Let's look at rates of change. We're looking at here are derivatives at a point. Okay, what do we call this? It is a slope, but it's got a name. It's called the difference quotient.
Oh.
It's called the difference quotient. It finds the slope, yes. It's the difference quotient of f at x point s sub 0 with increment h. So that's where there. Now, if h goes to 0, then the name changes to the derivative of a function of a function f of x at point x sub 0. And what that's denoted, it looks like this. So the derivative. No, derivative. So basically, if you want to, yeah. So much better when it's closed. All right, so what this tells us. So as h goes to 0 of the difference quotient, we have limit. Put it all together. So we have the derivative is equal to the difference quotient as h goes to 0. So that's a limit. Good. We just now define the derivative as a limit to a given point, because this gives us the slope of a curve at a given point, which is what the derivative tells us. So the derivative tells us the slope of a curve at any point x sub 0. So by definition, that is the instantaneous rate of change of a function. Let's take another example. So basically, all this thing really tells us is the slope. In examples 1 and 2 is last chapter, we studied the speed of a rock falling freely from rest near the surface of the earth. The rock fell at 16 feet per second squared during the first t seconds. And we used a sequence of average rates over increasingly short intervals to estimate the rock speed at the instant t equals 1. What is the rock's exact speed at that time? So how would you find it? Nope. What did we just learn? Because remember, is this the speed? No, what is it? The rock fell y equals 16 t squared feet during the first t seconds. This is a position function.
Oh, it's still not that position.
Yeah, so if we say at t equals 1, it fell 16 feet. At t equals 2, it fell 4 times 16, it fell what, 64 feet? And keep on going further, but that's not the speed. We're looking for the exact speed at t equals 1 or t equals 2. So how do we find that?
The slope of it.
Why would we use a slope?
So that one, except the-
Right, it's yeah, because the slope of a curve does show us the speed in which it's falling. So the slope is relative to the speed. So how do we find the slope of this equation? No. That's for linear equations. This is a quadratic equation because it has a square. What did we just talk about last page, last section, last 5 minutes ago?
uh,
We know the slope or the instantaneous rate of change is the limit as so we have to find the limit of the difference quotient. So f of x is equal to what? Because y is equal to f of x, the same thing. So then we have to find f of x plus h. (16t plus h squared).
all of that.
Because you add it to the t, not to the t squared. Now we plug everything in. There. So our slope is going to be the limit as h goes to 0 of 16t plus h squared minus 16t squared over h. What do you do next?
That's one for the kind of simple one, right?
Yeah, but we're not that far yet. I mean, we have to first solve this. Nope.
Oh, square root of two. Square root, I mean. Multiply.
Yeah, we have to do t plus h times t plus 8. Very good. Well, we can, since they both have 16, we could have factored that out. We could put 16 out in front. Not worry about the 16. So we have t squared plus 2th plus h squared minus t squared over h. T squared is gone. So we have 16 times the limit as h approaches 0, 2th plus h squared over h. What to do next? We're still working on this. They both have an H in common. That means you can cancel the H. Then what? We still have a limit here. How do we get rid of the limit? Yeah, take H going to zero, so H goes to zero. That gives us 16 times 2t, which is 32t. Now what do we do?
Just we have got 60. So into the for example now, I just multiply before we were putting it is equal to 0. Can I multiply it before doing that?
By 16?
Yeah.
Well, you could. I mean, you could have left 16 in there all along. Then you had 16t squared, 32t. Yeah, then you each of these. Well, it makes it easier. You don't have to worry about these big numbers. So
Because I used to do that for some of my previous classes.
Yeah. yeah, they're both okay. Because if you have a constant in all the terms, you can take it out and then worry about it at the end, or you can keep it. Bottom line is still going to get 32t. So, what is the exact speed? Mhm. $32 what? We're dealing with feet here, aren't we? Yeah, feet per second. If it was meters, it'd be 9 point something. 9.2. That's it. That's what that first section's about. Here's a summary of it. The following are all interpretations of the limit. Remember, this is all this. This is the slope. But when you put the limit in front of it, you now have the first derivative. It's the slope of the graph at point P. It's the rate of change. The slope and rate of change are the same thing. Yeah, this sums it all up together. So it's the derivative at x equals 0. And this is our x equals 0. X t0 equals 1.
Yeah, my problem is the problem is that's my biggest problem. When I started it's okay, but it's the starting part.
Okay, yeah, we'll work on those then. All right.
That's why we
Well, and we'll if you want to, we can do a lot more during class if we have time. Okay, so that does it for the first section. Goes take care of that. We should have time. This is chapter 3. Let me go ahead and stop here.